Hi guys, so today we are actually going to be spending our last day of learning new properties about circles. As you can see, I have a couple different circles going on here. I have this watering can, I have this roll of toilet paper, and I have this weird circular Halloween platter. And we're going to use these objects to help us learn some things about circles. So I'm going to start with the toilet paper. Seems topical. And what we're going to be focusing on specifically is the circumference and diameter and their relationship between the two, and then we're going to move on to some things that use that information. So first things first is let's review the vocabulary. Circumference and diameter are both terms we introduced in that story time, that picture book I had you guys watch the YouTube video of. So go back into your memory bank and tell me what you think the definition of circumference is. And also what the definition of diameter is. Okay, so now let's review. Let's see if we remembered. So the circumference is the distance around a circle. So it's very similar to perimeter, but perimeter is used for polygons, and we use circumference when we're talking about a circle. And then the other term, diameter, is the distance from one end of the circle to the other, passing through the center. So it's a chord that passes through the center of the circle. That's the diameter. So those are the two measurements we're going to be working with. I have this measuring tape that's kind of bendable that allows me to actually measure the circumference exactly. I'm going to be dealing with centimeters today, and I'm going to be recording my information in this table. So here I first have my piece of my toilet paper, and I'm going to first measure the circumference in centimeters. So I'm going to just take my measuring tape, wrap it around, look at it, and I am going to record the distance around, which was 36.5 centimeters. Okay, and now I'm going to do the same thing for the diameter. I'm going to measure from one end to the next, and when I look at that, it's a little bit more than 11 and a half, so I'm going to round it up to 11.6. Now, mind you, this is a little bendable, so my measurements aren't going to be perfectly exact, but I think I did a pretty good job. So now what we're going to do is this calculation of the circumference divided by the diameter. So what you're going to plug into your calculator is 36.5 divided by 11.6. So plug that into your calculator and tell me what you get. All right, so you should have an observation. Now we're going to move on to the watering can. So my watering can is a little bit larger than the toilet paper, but we're going to do exactly the same thing we just did with the toilet paper. So I'm going to measure. Oh, it makes it a little bit more challenging when it gets bigger. Just wait until it's the Halloween platter. That's when my job gets a little bit more challenging, guys. See? Third time's a charm. And you can do this with anything in your house if you have this kind of measuring tape. You can also use a piece of string and then measure how big the piece of string was. So that's my measurement, and when I check in centimeters, I get that it was almost exactly, so I'm going to use that number, exactly 45 centimeters. Okay, and now I'm also going to do what I did with the toilet paper, and I'm going to measure the diameter across. And when I do that, I get approximately 14.3 centimeters. And once again, I want you to do that calculation. What is 45 divided by 14.3? Write that down into Edpuzzle. And now we have our last circular object. This is when it really puts me to the test. See if I can try to do my best of wrapping this around. All right, so far so good. Maybe not. I'm going to put the pencil down to really make this a little bit better. Okay. So close. Once more. See, guys, this is why it's helpful to do this stuff in school with maybe an extra pair of hands just to have it hold on, but that's okay. Okay, so I got it this time. And when I measure that and check the measurement, I get that the distance is 94.2 centimeters. Okay. Last measurement we're going to do the diameter, which is much easier, so this should be quick. In centimeters, and I get the diameter is almost exactly 30 centimeters. All right? Now, like you did for the last ones, please do those calculations. 94.2 divided by 30, and tell me what you get. So now I'm going to do the calculations myself just to make sure that you got the same numbers as I did. So I'm going to do 36.5 divided by 11.6, and I get this number of 3.14655, and so on. Okay? Now let's do that calculation for the watering can. So 45 divided by 14.3, and I get 3.14685, and so on. Okay, and the last one, 94.2 divided by 30, and we get just a clean 3.14. Interesting. So now what I want you to do is look at that data and let's see if we can come to a conclusion. When we did all of these very different sized items, right? The toilet paper was much smaller than the Halloween platter. When we divide the circumference divided by the diameter, we keep on getting a number up at approximately what value? And do you know what what special name we give to that number that is approximately 3.14? For those of you who don't hopefully know it at this point, it is pi, and it is my favorite number. In fact, I know 28 digits of pi, and I'm going to do it for you right now because we missed Pi Day at school, so it is 3.14159265358979323846264338, and then I always mess up from there, but this is the ratio between their circumference to the diameter. That is what pi is, and this number goes on and on and on forever. But all it is just this special ratio, this special relationship between circles. And when we first discovered pi, like centuries ago, we knew it was like a little bit more than 3. And then mathematicians figured out it was about 3.1 something. And it's just gotten more and more precise. In fact, there's mathematicians all around the world that are using pi and trying to find more numbers, digits of pi. So now that you know that, we can actually use this information to determine what is the formula for the circumference of a circle. So if you know the diameter, we can also then figure out the full circumference. So knowing this, if we know the diameter of a circle, let's say the diameter of this circle is 8, all right? And we know that the circumference is about 3.14 times larger than the diameter, we can calculate the circumference as diameter times pi. So we can calculate the circumference of this specific circle by doing 8 times pi. And it's okay to just keep your answer that as 8 pi, or you can go one step further and do the calculation on your calculator. 8 times, and what we're going to use is approximately 3.14. So if you did that properly, I want you to try it yourself, and I'll also do it. 8 times 3.14, we get approximately the circumference of this circle is 25.12, and let's say centimeters. Let's say we're using centimeters like we did this whole time so far. All right, so I'm going to give you 2 questions in addition, and then we're going to move on to something a little bit different. How about I give you a problem where I just give you the radius, and I tell you the radius is 6. The first thing you have to do is tell me how large the diameter is. So if the radius is 6, how large is the diameter? And if the diameter is 12, because remember the diameter is always double the radius, then we can calculate the circumference by doing what? What would you get as your calculation? What are you going to plug into your calculator to find the circumference of this circle? So you should be plugging in 12 times pi, or 12 times 3.5, silly me, 3.14. And when you do that, you get 12 times 3.14 is approximately 37.68. All right, and one more that's a little bit different. What if I tell you the circumference is, let's go with 50 centimeters. And I want to know, how long is the diameter? What do you think you could do? How could you set up your equation to solve this? So the way we're going to set this up is we are going to plug in 50 into our equation here. And instead of plugging it in for the value of d, we're going to plug it in into the circumference. So 50 is equal to the diameter times pi. And then in order to find the diameter, how are you going to get the value of d all by itself, the value of the diameter all by itself? We're going to divide by pi. So pi goes away on this side and we're left with just the value of d. We'll divide both sides by that. So this, we have the diameter is equal to 50 divided by pi. And what do you get when you do that calculation? All right, when you do that calculation, 50 divided by approximately 3.14, you get the diameter is about, rounded to the nearest hundredth, 15.92. All right, that's all we know about circumference. And I'm going to stop here for a second, and we're going to switch into the next portion of this video, which is going to talk about arcs, so portions of the circumference.